Today we're going to look at slope again. Day 2. So last day we learned how to calculate slope. We find 2 points and we figure out the vertical distance and the horizontal distance, and we write those two numbers as a fraction. Math people want numbers. We also learned that slope can be positive, going up from left to right, negative, down from left to right, 0, flat, or when it's vertical, undefined, and we won't worry about it. Today we want to continue on with slope, and we want to recognize a really important idea of slope, and something that will actually help us out a lot. So what I'd like you to do is pause the video and pick 4 nice points on this line and calculate the slope from A to B and B to C and A to C and A to D. So whatever points you pick, it really doesn't matter. So pause the video, pick some nice points, label them A, B, C, and D, and then calculate the slope on the little parts that I've asked you to do. Okay, so on my graph, I'm going to pick this one. I'm going to call it A. This one, I'm going to call it B. C, I'll pick at the origin. Always try to pick a nice one. And I'll pick D way over here. So here are my points. And what I'm going to do is I'm going to do my quick slope calculations. And instead of vertical and horizontal, I'm just going to say up, down, left, right. So from A to B, here's what we have. To go from A to B, I go up 1 and I go right 3. So up 1, right 3, and that tells me that the slope from A to B is equal to 1 over 3. So I just wrote a letter, and this is the letter that's going to represent slope. And it comes from, I think, I should actually check this out. It comes from the French word montagne, mountain slope. Don't comment and say you did. That's BS. It sounds good. Slope from B to D. So from B to D, we're going to go up 3. So I'm going to go from B to D this time. And I'm going to go right 9. So up 3. Again, that's up is positive. Right 9. Right is positive. So the slope from B to D is equal to 3 over 9, which is also equal to 1 over 3. So sometimes it's really good to reduce your fractions. Okay, AC, the slope from A to C. So if we look at A to C, well, to go from A to C, I'm going to go up 2, and I'm going to go right 6. So again, up 2, right 6. So the slope from A to C is 2 over 6. Remember, vertical over horizontal, and 1 over 3. And finally, from A to D, I won't do it on the picture, but from A to D, we would go up 4 and right 12. So the slope from A to D is equal to vertical distance, horizontal distance, and we can simplify to 1 over 3. So again, what I hope is very obvious, and I hope it's very obvious from the graph, that the steepness of this line does not change. It is a straight line. It's not a jagged line. And last day, we saw something important. We saw one of the characteristics of a linear relationship is there is a constant pattern. There is a constant rate of change. And that's what we're seeing today, except today what we're seeing is the same slope. So here's a question I asked the other day. What makes a line straight? And again, we said constant rate of change. We said a pattern. A pattern in the table, a pattern in the graph. Well, I hope you see a pattern in this graph. And the pattern is we have the same slope. So the big idea that I hope you see with this straight line and every straight line, there is the same slope between any 2 points or any 2 points on the line. So this turns out to be really good for us. This is really important. Remember we said slope is a line word last lesson. And if the slope of a line is important, which it is, then we're going to have to find the slope of the line. And what you've just seen is, in order to find the slope of the line, you just need any 2 points, because we know it doesn't matter which points you pick. We're always going to have the same slope. So this allows us to pick the nicest possible points we can, and it really doesn't matter. So again, I think if I ask you how many points you need to draw a line, well, you only need 2 points to draw a line. And if we know 1 point slope, we can use the idea above, which is called the constant slope property, constant slope property, to draw a line. So that's what we're going to do next. We've just determined how to calculate slope last lesson. Today we're continuing on with slope and showing that, well, straight lines always have the same slope everywhere on that line. And one of the things that we're going to do in this unit is we're going to draw lines from now on, and we're going to figure out the equation of the lines from now on. So slope is a really good way to do one of those key ideas, draw a line. So if we look at this first example, here's what I want to do. I simply want to draw the line, and again, I want you to use a ruler. This computer doesn't let me stick a ruler on the screen, so I'm going to draw the best line I can, but I want you to draw a ruler. So if you don't have 2 points, how could you draw a line? Well, you can use slope. So what we're simply going to do is we are going to plot a point and use the slope to draw the picture. So before we go ahead, what I want you to notice in this one right here, m equals 3 is not a good way of thinking about the slope of a line. The slope of a line is the comparison of vertical to horizontal. So when you just have an integer, like 3, the slope gets hidden. Whenever you have an integer, it's always better to make that integer into a fraction. That way we see the vertical distance on top, we see the horizontal distance on the bottom. So I'm going to color code my lines. This is going to be blue, and the other one will be green. So here's what we can simply do in order to draw this line. We could plot the point, 4, 5, and then we could use slope to tell us how to get to another point. So this is slope is like a traffic cop. If you come to an intersection and there's a detour, the policeman will say, go down this way and go over that way. And that's exactly another way to think about slope. So a slope of 3 over 1 means positive 3 over positive 1. I go up 3, I go right 1. So again, this slope of 3 could be up 3, positive, right 1, positive. But it's always a good idea to have 3 points to draw a line. So instead of going up 3, down 1, we could also go down 3, left 1. And if we went down 3, left 1, I hope you see that your points line up. So what I'd like you to do now is connect that with your ruler, and I'll just do the best I can right there. Now, I'd like you to draw the lines right through the grid. Don't stop at your points. Remember, lines go on forever. So here's our blue line, and we use slope in order to help us draw that picture, given that we did actually have 2 pieces of information. So in our next example, again, same idea, but now we have that negative slope. So we're going to plot our negative 2, 6, Negative 2 comma 6 is up there, and there is our slope. Now, the negative, this negative, it doesn't matter which number you use it with. So given that we know a negative slope goes down from left to right, that's all we could do. In this one right here, what we could do is imagine going down 1 and right 2. And if we went down 1, that's our negative, and right 2 would be there. And if we connected those dots, we would have a negative slope. So slope allows us to draw our lines really quickly, really nicely. And again, it's this idea of slope as a traffic cop. So given that we know a point and a slope, what that slope allows us to do is figure out an infinite number of other points on a line. So here's an example of determine 3 other points on the line defined by the given point and the slope. So 9 comma negative 1 is right there. And our slope of negative 1 over 3 says go down 1, right 3. Well, if we went down 1, right 3, we're off the picture. So in fact, this one, I want to go up 1, which would be the positive part, and left 3, which would be the negative. So if we went up 1, left 3, we get to there. Up 1, left 3, we get to there, and so on, and so on, and so on. And what you could see, as long as I'm using the same slope, my points line up. Same pattern, constant slope. So 3 points that I might choose would be 6 comma 0, or 3 comma 1, or 0 comma 2. So there's an infinite amount of them. I'm just picking the first ones. Now, one of the things I want to start highlighting is that slope isn't the only important thing about a line. There are other important things. So here's a question. Where does the line cross the y-axis? So our y-axis is always our vertical axis. And where does this line, again, I'm not going to connect the dots, but you should. Where does this line cross the y-axis? It's right there. So the line crosses the y-axis at 0 comma 2. And this is also called the y-intercept. So a little language right now, and we're going to build on it in future lessons. So again, our slope can help us answer other questions about lines that we may have. So here's a bit of a challenging one. We want to determine the number k that goes right there. So basically what we have is we have 1 point on a line, we have slope, and in this question, I don't want to know any other point. I want to know a point that matches up with an x value of 3. So here's this idea I said before. Sketching a picture is a really nice way to help you understand what the problem is. So in this one, the first thing I'm going to do is I'm going to plot 4 comma 7. 4 comma 7 is right there. Now, this number right here tells me the x value of my other point. Oops, sorry. 4 comma 7 is right there. Right there. And here's what we want to do. We want to figure out what that number is, but x is equal to 3. Now, I can't assume it's going to be a nice number, but it'll turn out to be. So here's really what we know. We know that everywhere along this highlighted line, the x value is 3. 3 comma 1, 3 comma 2, etc., etc. And really what I want to know is what is the y value on that, somewhere on that highlighted area where the line that goes through 4 comma 7 also has a slope of 4. So remember, slope of 4 is not a nice way to understand slope is a traffic cop. 4 over 1 is better. So if we went up 4 and right 1, I hope you see that you're actually moving away from where you want to go. So in fact, in this one, we want to use our slope as a down 4, right 1. And really down 4 and left 1. And what we would really be doing is we would keep on doing that pattern just like I did in the example above until we got to where we wanted to go. And in this one right here, when I go down 4 and right 1, in my very first go, I actually hit it. And if you look at the coordinate then the coordinate would be 3. So 3, 3 is the other point on the line that goes through 4, 7 and has a slope of 4. So again, slope is this measure of steepness as a number, but slope is also a way to go from one point to another point. And I think that idea of slope as a slope of a traffic cop is a really good way to help us understand the pattern and thinking of slope in a little bit different way than just a plain old number that might not make sense. So a couple other things that I want to introduce that slope helps us find is this idea of an x-intercept. Almost every line has an x-intercept in it. Almost every line has a y-intercept. And the x-intercept is the place, which is a coordinate, not a number. It's a coordinate. And same with the y-intercept, where the line crosses the x-axis, and the y-intercept, as I said before, is the place where the line crosses the y-axis. And again, slope can help us find this important information. Generally, you only need 2 points to draw a line. But sometimes I'm going to ask you, where does this line cross the x-axis? Where does it cross the y-axis? So this slope as a traffic cop really helps us there. So let's have a look at the first one. -6, -8. Now I'm just going to do a bunch of dots again because I can't stick a ruler on here, but you should connect the dots and make sure you see. If we're lucky, we can actually see exactly where this line crosses. So here's all I'm going to do. I'm going to use this slope information in order to see where this particular line will cross the x and y axis. So all I'm going to do is go up 2, right 1, up 2, right 1. So here's up 2, right 1, up 2, right 1, etc. And there we have the x-intercept right there, and I'll just keep on going, and there we have the y-intercept right there. So here's our x-intercept, there's our y-intercept. The x-intercept is -2, 0. Remember, it's a coordinate, and the y-intercept is 0, 4. So in this one, we got really lucky and figured out that pictorially, I see the exact answer. So that's good. But again, slope as a traffic cop allowed us to do that. Let's look at 2 other quick examples. So 5, -9 is right here. And again, a slope of -2 is better thought of as that. Now remember that negative, if I took it like this, the negative would be down 2, right 1. But then I'm off the graph. So instead of going down 2, right 1, I'm going to go up 2, left 1. And again, if I did that, I'll do the first one, up 2, left 1. And if we connected those dots, that would be a negative slope. So I'm going to keep on going up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2. So again, what you see is, wow, we have a nice y-intercept, but we don't have a nice x-intercept. Now you've drawn the line, right? You've got your ruler and you've connected those dots, and you probably have a good idea of what it is. So in this one right here, the y-intercept is very obvious. It's 0, 1. What do you think the x-intercept is? And if you looked at it, and if you drew a quite accurate picture, you could probably see that it is 1/2 or 0.5, 0. Instead of going up 2 over 1, we go up 1 over 1/2. And finally, the last one, which is a tricky little one, 4, 2 is right there. And if we, again, use the up 1, right. So slope is up 1, right 3. We're actually moving further away from where we want, so we're going to go down 1, left 3. So down 1, left 3 gets us there, down 1, left 3 gets us there, down 1, left 3 gets us there. Again, you're going to connect that. You're going to connect the dots, and our x-intercept is the nice one here. You see it, it's right there. But our y-intercept, again, if I drew the line, my y-intercept, it's not nice. So our x-intercept, I do know, -2, 0. My y-intercept, well, I don't want to guess, but I'm going to give you the answer. I want you to see if you can figure out how that came. And if not, this is something we might discuss in class.